All right, back with the video. Today we're talking about learning PyTorch from scratch. So PyTorch describes itself as a tensor library, and tensors are kind of like the fundamental unit of what neural networks and machine learning models use to learn. It's kind of like the building block. We've got an F-14 Tomcat here for any military aviation folks. But the motivation for doing this is with ChatGPT and GitHub Copilot, the threshold to get into AI, ML, and software engineering is lower and lower, which is a good thing overall. But I think what will separate an average developer from an advanced developer going forward is building as close to the bare metal as possible. So something like PyTorch, you can train it on, the tensors are loaded on the GPU. So you can run models on thousands of GPUs and scale your model up. Whereas if I'm being honest with myself right now, there's certain machine learning libraries that I know, PyCaret, which is very low code, some TensorFlow, but I think learning PyTorch from scratch will force me to learn the core values of machine learning and the mathematics behind it even, which hopefully will set me apart from people that are just typing stuff into ChatGPT and taking whatever it spits out. So um, when I say from scratch, I have to give a couple caveats. I have never used PyTorch prior to like preparing for this video, so that I guess is from scratch. But I will say I'm a pretty good Python developer. I have a surface level understanding of AI and machine learning. I've never taken a linear algebra class. I think the highest one I took in college was Calc 3. So a lot of the fundamentals of machine learning are linear algebra based. So I have no bearings there. So we'll be learning this from scratch. I feel like there's quite a few people in my boat here that they may know Python, they may know the terms associated with AI and ML, and they might be able to train a decent model. But learning PyTorch and even more fundamental libraries like TinyGrad, which hopefully we can do that in the future, it'll set you apart, I think. So yeah, PyTorch is a tensor library. Tensors are a mathematical construct used to represent data. Translating it to NumPy, I believe a NumPy array and a tensor, PyTorch tensor, are identical, except for the fact that you can store tensors on a GPU, which opens up the possibility of parallel processing, which could scale up the training of the model, speed up the training of the model, that kind of thing. Yeah, so when you're translating your data into tensors, into something that the computer can read, that would be a tensor. Also, the weights and biases that make up the model, those are also tensors. So, yep. Here's kind of a representation of different lists of numbers. So a scalar would be a single number list. A vector is 1D, so it's just a list it's just a single list. A matrix could be a list within a list, but it's still only one or two dimensional. And then at the bottom here, a tensor is three dimensional. So a lot of this stuff I'm taking from the PyTorch documentation. Future videos in this series, I'll actually be writing code and maybe I'll translate it to something that my subscribers like. I don't know, I make a lot of sports videos, so I might be able to translate it to that or something. So I don't know why. I mean, PyTorch gives you the ability to like initialize tensors. You can initialize a random tensor. You can initialize a tensor that's all ones or all zeros, and you can define the shape here. I'm not exactly clear why you would want to, initialize a tensor from scratch. I would always think um, you'd start with translating your data into a tensor, but maybe it'll become more clear to me as we learn more about PyTorch why you would want to do operations on raw tensors. So attributes of a tensor, these are just kind of some methods you can run on the tensor class. So you can get the shape of it, the data type, and where it's stored. So again, as I've been mentioning, one of the benefits of PyTorch is you can run it on a GPU. So you want to know at all times where your data is stored and where your tensors are stored, because if you're renting GPUs on the cloud, you definitely want to be using those. You don't want to be running on the CPU and wasting your time and money. So yeah, again here, if you wanted to see if your tensor was on the GPU, you could run this CUDA is available method. So CUDA is another library I'm not super familiar with, but it's a Python library framework of sorts that you can use to run things on the GPU. So I think this can go beyond just machine learning. GPUs were actually originally invented for video games. So I'm sure a lot of game development uses this CUDA framework. And I believe that PyTorch does a lot of the work on CUDA, behind the scenes, so you can just move things to the GPU with a simple couple lines of code. Whereas if you wanted to get really technical with it, you could open up CUDA and try and figure out how to implement things on the GPU yourself. So that's definitely something to learn about more in the future. So not going to get super in depth with code or anything today, but obviously, in my opinion, step one of any machine learning project is the data set, what you're training it on, the features and labels. So PyTorch, in this case, has two classes that you can use. Number one is the dataset class, and number two is the data loader. So these both are classes, but in the documentation, I'll show you the code in a minute, they also have you implement this class within another class. And the reason they do that is if you wanted to define your data set, let's say you have a CSV of your data set, and you wanted to try out loading it one way, let's say like shuffling it randomly and seeing how that affects the training. And then maybe you're like, that didn't work. Let's see if I can try not shuffling the data or shuffling it differently. That the putting it in a class makes it object oriented, so you can quickly switch out and try different parameters of the class and see if that affects the model training at all. So I like that part of PyTorch. So let's start with the dataset class. There's three components: the initialization function, the length, and the get item. So the initialization function is here. You would define like the file. If you got a CSV of data, you would define the file path here. This is more or less the pre-processing. So if you maybe were using another library, like for example the NFL Python library, you would define how to pull the data in the initialization function. And then if you wanted to transform it in any way, maybe join the features and labels together, if there's any metadata, any other stateful elements that you'll be using throughout the length of the existence of this class. So the next method is the length method. So you're going to define the length of the data set here. And last is the get item. So I'm not 100% clear. Maybe it'll become clear when we start writing code, but the initialization function versus the get item, I believe you're just kind of writing definitions in the initialization function, and then the get item is what you're actually executing. So when you start up the class, I believe the get item function is what will actually perform the task. So this is an example of a dataset class. You can see they're defining, read the CSV to get the labels, the directory, where the images are. This is an image data set in this case. The transform. So, like I said, this is kind of modular, so you can try out transforming or not transforming the data in whatever way you want and see how that affects the model without having to rewrite all your code. You can just call another instance of the dataset class. Length, pretty self-explanatory. It's just the length of the labels up here. And then the get item is where you're actually, okay, let's read the directory where the images are. We're reading, transforming if you've specified that you want to transform, and then returning the data. All right, last thing, the data loader. Most of the heavy lifting, it seems, is done in the dataset class. The data loader is just where you would define the batch size and, if you wanted to shuffle, anything you want to do to, adjust how the data is loaded in. This also seems like where you would define, you would separate the training and testing data. So that's all I got for today. I hope this is helpful for somebody out there. Making these videos forces me to learn things and put thoughts into a presentation of sorts. So I'm going to keep learning PyTorch. Next video, I think we'll actually write some code and I might try to relate it back to sports or something. So thanks for watching.